Technology Officer, Philipp Schmid.
Good morning. I'm excited to give you an update on the GV2 Just Add Audio that we've introduced last year. But to be truthful, we've been on this journey for a few years, so I'll start with a bit of a recap as to how we started the whole thing. So going back to 2020, we had a webinar series, a three-part webinar series with TELUS Alliance at the time. That's where we kind of kick-started the concept. And I think it's important to reach back because there's so many different concepts that I hope I can piece the puzzle pieces together for you, how it all comes together and how it fits into the GV2 overall. So this three-part series, it focused on made-for-radio standards first, then moved into a couple of different things in terms of how we solved the diversity delay problem for HD radio, and then a new way forward, and well, that new way is here now. At the time, we wanted to reintroduce or go back to network or protocols and standards that were developed specifically for radio, and composite MPX is specifically tailored for FM. But we found that's kind of fallen a little bit into disuse in recent years, or a lot of people weren't quite aware as to how important that is. So we refreshed that concept a little bit. But we also put the E2X beside it because we see E2X as the protocol used for HD radio to transfer the encoded audio to the modulator, which is the same thing that MPX does for FM. It encodes the audio into a special format and transfers it to the modulator. And once you realize that those two components are pretty much side by side, we've introduced a new system architecture where we have an air chain that takes a single audio stream, whether for FM and HD radio, at the input, at this what we call the split in the audio processor, and we came up with a synchronized architecture, and more importantly, a synchronized modulator that takes both the FM and the HD into account, modulates the signal, and puts it on air. And the key thing here was from audio split, where the FM and HD1 split, to where they rejoin in the RF waveform, we control all the delays in between. And that MPX E2X protocol in the middle, you see that transfer in orange and red on that screen. That is really the key protocol that keeps that all together. So with this, we're able to demonstrate that we can solve the FM HD1 diversity delay problem. It no longer slips. It comes up the same every time. You reboot any part of the system, comes up the same way. We use the exact same value for 4 years now. So all of this chasing and hunting, what your delay is, it's a thing of the past. Yeah, and that's really what that slide was talking about. So you can measure that with, Innovonics Justin receiver, for example, and the diversity delay problem has been fixed. We took that demonstration a little bit further, and Alex Hartman, my colleague at the time, we had a little bit of fun. So we set up a system in Amazon Web Services where we originated the importer, exporter, and audio processing in the cloud, AWS, in the Ohio data center, and we fed a transmitter in at Nautel labs, and we measured the diversity delay. Even though there were thousands of miles between us, diversity delay is always fixed. And I want to add, there was no GPS involved, no time tagging. It is this architecture that did that. Well, we had a little bit more fun after that. So we cloned, now that we're all in a software-based air chain and we've been able to eliminate all of our hardware dependencies, we're simply able to clone our air chain into different portions of the AWS data center. So we had one in Ohio, two of them in Ohio actually, moved one into the Oregon data center, and just for fun, we moved one down to Sao Paulo in Brazil. So we had a system set up where all those four air chains were feeding our transmitter, but only one of them, of course, is active. So we had them all fail from one to the next, all the way over, and the diversity delay, always fixed. Even when I switched over to Sao Paulo, and even though there was a significant, I think, 200 millisecond ping delay across it, didn't matter. In our system, that's all accounted for. So that was a fun webinar series a couple of years ago. Now, COVID happened. So the next sort of public announcement was NAB 2022. Just getting over COVID. It was a smaller show, a lot fewer people than today here. But that's where we showed our first proof of concept. That's where we showed our GV10, GV1 at that time, the original GV on the show floor, being fed from Amazon Web Services. So right on the show floor, we're demonstrating we're able to get a feed from the web on the entire content, FM, HD 1, 2, 3, 4, artist experience, all of that originating in the cloud, directly feeding a transmitter. So other than an Ethernet cable, there's no hardware boxes. And at the time, I forgot to mention the previous slide, I submitted a paper to the Broadcast Engineering Conference detailing particularly this kind of protocol, this approach that we're doing. And it's really the concept of sending that MPX and that E2X for HD radio in a single pipe, so it can no longer slip. That's really the basic, simple concept behind this. And this allows us to put all of this data services from HD 1, 2, 3, 4, program service data, RDS, all of these separate components into a single data pipe. And that's what allows us to fail over to the other ones because we have everything in one pipe. And therefore, we're able to switch over from one to the next. A key part of this system here is we introduced what we call an air chain selector. Now that we have this one protocol, this one pipe, being able to fall back from one to the other, and that's essentially the demo that we had set up. We had a cloud air chain that was on AWS. We had an on-premises air chain that was running on essentially an HD multicast. And we had a backup air chain at the site, closer to the GV10 in our demo setup. But we're able to demonstrate that we could use multiple Ethernet links, as you show in the green path, multiple TCP paths, disconnect Ethernet wires, and it's always on air. Once you lose all of them, then it could fall back to another stream. And we're able to demonstrate that we can gracefully fall back from one input, keep an HD radio receiver locked to the same signal when we switch, which is unique. Ask anybody else to demonstrate that to you. That's a unique thing that we can do. So when you're on the cloud air chain, and let's say your link fails, you have to go to backup air chain, your HD radio receiver stays locked. It may be different audio content because you may not have, now if your link failed, you might be on a backup playout system. And it does a graceful blend when it goes from one stream to the next. So that was a very neat demonstration we were able to do there. But keeping that air chain selector constant in the back of your mind, we're going to come back to that in a little bit. And that air chain selector lives in the transmitter, of course. It's one of the last steps just prior to the modulator. How are we going to feed that modulator? Is it stream 1, stream 2, stream 3? That's in the transmitter. Just keep that in your mind, and we'll get back to that. NAB 2023, that's where we first introduced that GV2, or GV squared, as Jeff wants to call it. And the neat thing about that is, well, first of all, it goes back to, we asked the question, how did HD radio get so complicated? And we get the feedback from you guys that HD radio is the most complicated install to do, and anything that you guys do. And so many boxes, so many interconnects, so many points of failure. All the more audio processing, more STL requirements. Now you might have to have a diversity delay correction box in play. And of course, then the transmitter itself has power levels and things like that. There's a lot of complication there. How can we make that simpler? So now we have everything in the transmitter. Essentially, you just give it live wire audio, and we take care of the rest. So we showed 3 main screens last year at NAB. We showed that we had the new HTML5 user interface, and yes, now, as John was saying, he's going to give a few of those away. It's finally there. We showed the HD radio interface in the GV, and we showed the Omnia for Nautel as a separate screen right in the GV. So that was last year's demonstration. And now just got a couple better shots in there. So there's the new AUI. So we've got a setup on a show floor where we dial into a GV at the factory, and you can play with the UI. So that's part of the demonstration today as well. Of course, HD radio is now right in the transmitter, so no separate importer, exporter, no embedded exporter box. It is actually right in the transmitter. It's just a software load, and we'll get into that a little bit more. And of course, the Omnia for Nautel. Remember the split to join. That is the ingest of our audio. That's where the single point of audio is getting ingested, split, and processed separately. Fast forward to this year, our demonstration this year is focusing on emergency alerting. So we have a demonstration set up where we actually have two air chains. One would be a main air chain, and it could be in the cloud. For simplicity, I just have it running on an HD multicast today, but we've demonstrated the cloud previously. So that would be a main air chain, and we have a separate dedicated air chain for emergency alerting. And that's what we have the DAS deck system set up. And the VIDs, the graphical symbols that Bill referred to, there's the 4 symbols we chose. In particular for Las Vegas, I picked the tsunami warning because I figured that's probably not a concern here. But you never know. So anyways, that's this year's demonstration. I'll get back into that a little bit in a little bit more. And come see us, and we'll give you all the ins and outs of that demonstration. So where are we with GV2? Well, glad to say we have 2 stations on air. First station on air is CFRQ in Halifax. It's a Stingray station, Q104, a rock station, and we've got engineer Matthew Gilly here in the picture here on the right. They were the first ones on air, and we also have KVSE, Alex Hartman's station here as well. First, let's have a closer look at CFRQ. So CFRQ was the first install we had. It's a rock station, and pardon the pun, but fully intended. It's been rock solid since we put it on air. We had a couple wrinkles where we had to get the Arctic Palm RDS massaged a little bit to get playing into our playout, but the RDS is working with that as well. But they've done a fantastic job of working with QU to get the artist experience going. And it's a great demonstration system, and we love to have a great HD station right in our backyard. So we like to make that a showcase. And I believe we have Chris McLaren in the audience today. I don't know where you are. Oh, right here, yes. If you have any questions about the install or what their experience were, come talk to them. And certainly, I think we want to take that even further as to what we have today. Now, Alex Hartman, he's doing duty on the show floor today. We had to make sure our demos are running. He's over there right now. But we had AirChain running initially in 2022 as a very early, weekend trial kind of thing. So we had that running on his original GV. But we have Jim Gray today here with Optimized Media Group. And maybe you can talk a little bit about the install at KVSC and your experience with AirChain. So that's the second station on air with this AirChain approach today.
Thank you. All right, there we are. Yeah, as you can see, we have our original GV running on the right side. Hello, there I get my hand off the antenna.
I can use this microphone.
No, we're good, we're good. So on the right side, we see we have our original GV that was introduced exactly 10 years ago. Our manufacture date is within a few days of being exactly 10 years apart. Brought in the new GV2 installation as any other GV would be. We had it operating in analog in just a few hours. And then Alex Hartman, who really deserves the bulk of the credit for all of this, worked on getting the software in and running, and we are currently using almost all of the capabilities that a GV2 offers. We are running currently 4 HDs. We are getting, once Philip gets some things done for us, we'll be looking at the MP11 and launching an HD5. We already have our content stream created for that. We're running redundant STLs for testing purposes. So we like to, when we're doing testing on things like this, a lot of beta test work with what happens if you lose connectivity. So we have a 5.8 link, we have a licensed 6 gig link, we have a 950 analog link, and a backup 2.4 link to those. And what happens if any of those particular things die? What happens if I lose internet connectivity and I need to go back to my backup GV that needs hardware for processing? We're also running separate electrical services for each of those two systems completely independently, so I can measure power draw under one scenario and power draw under a second scenario. So like I say, we're using a lot of the features on this. We do have the Omnia for Nautel is running the processing for the analog and the 4 HDs. that's currently running out of the GV2. In all told, it was about a 5 or 6 hour install for the unit, and then about that for Alex to sprinkle his magic dust on things and get the rest of the software working. But I thought it was a pretty cool shot having the original GV and the GV2 running side by side right there. And yes, Jeff, you can see I've got everything installed, right? Okay. There's the ferrites. All right. And if you guys do have any questions, I'll be around during lunch or afterwards, or you can find me out on the show floor or elsewhere. So.
Very good. Well, thank you very much. Excellent. So that's the exciting news today, is that we have 2 stations on air. But maybe I'll give you a little bit more of a detailed rollout plan, and that's how things are going. For the Keen Observer, it's still running the Flash UI here. So we're going to add in the new UI as John already mentioned. We have it here now. But how does it all fit together? So as John White mentioned earlier, new AUI running, let's call it bare metal, is what we're releasing right now. So the next thing we're going to do, and we already have that running on the show floor, and we already showed it last year as well, but it's the idea that we're turning what's running bare metal today into an app. Think of it as an app. So what makes a GV2 is the virtualization engine, and we're using Proxmox as the technology underneath it, but it is an application engine that allows us to put in different broadcast apps. And over time, we will develop different applications, one after the other. So you have to rethink. No longer do we have a monolithic GV software release. No, the first release that's going into production like that will be your production release, but it is an extendable application platform. GV2 will support everything that GV1 does. So we can still run, of course, analog FM mode. We can install our current XGen card. So GV2 is GV1 plus. So there's no, you have to choose one or the other kind of things in there. Anything that GV1, the original GV can do, GV2 can do better. So we're taking orders for that now, and we expect a production changeover from GV to GV2 in the summertime frame. There will be a bit of back and forth in terms of when that exactly will happen. So if you have a need to run a third mode with a new interface card that uses those new software air chains, then you need the GV2. But if you want to run in analog mode, then either one will work. One new aspect that we're adding to GV2 as well is because we're adding this new engine, this new Proxmox engine, we envision we'll have to have greater support for you. So we're adding a remote support where when you enable support in this screen, it will reach out to our support server and open up a back channel to our support staff to get in and get to sort of all the details that you can configure with the system. We don't imagine that you will have to configure a whole lot, but if our customer service needs to get in there under the hood and give you some help, we can do that. And we have that running both on CFRQ in Halifax and KBSC in Minnesota as well. So we're able to get into those systems, do the low-level support, and when we're done, you can disconnect the remote support again. So here's just a shot of how we envision the apps to work. So we'll have a new updater screen where you'll have to walk up with a USB. It may have a new virtual machine on it with a new app. You hit the button to install it, it will install it, and it will become active. So first app, it would be the XGen, we call it the V for virtual, XGen application. And that's a modulator, but it modulates both the FM and the HD in one shot. And it's based on Xperi's Gen 4 code, and as I mentioned earlier, it is synchronous so that we can fix the time and diversity issue with that. That's the first app. Then the second app we call the V-Porter. It's a bit of a play on the importer. We called it Cloud Porter at one point as well, but it's not always in the cloud. So V, a virtual porter, is the name that we use for now. And that's a Windows application. So we can run a Windows system alongside Linux systems here. You can see the penguin for the Linux systems and the Windows logo for the Windows systems. But the reason why we're doing that, and I should mention, those two apps are in sort of a controlled release state, and that's what we're running on the 2 stations right now, those 2 apps. We envision those to become official in the second half, starting with the XGen first and the vPorter second. But the important thing here is they're not part of your GV software release. They're apps like in your Play Store or your App Store. They're installed separately. The base is the app platform. That comes with your GV, and then you add in what you need to run. And over time, I envision different apps coming along here, depending on the application needs that we need. So taking it a little bit further. So one important thing here is you can run our software air chain where you want it. You can have it all in the GV as shown here. In that case, you have to apply a license to the code inside that. That activates it. So it's really about that license file. There's a license server involved here, depending on whether it makes sense to install it within your organization or use our organization, or even use the TELUS Alliance server. All those are options, but it has to be activated with a license file. Now that since we are entirely software, you can clone the air chain, and we're working on a Windows installer right now. So essentially, you can take that exact same piece of code, put it where you want. Whether that's in your data center, your own virtual system, it just has to be a Windows platform, and we'll have some minimum requirements, of course, what it needs to have. But it is a Windows application that takes LiveWire in and then creates a data pipe, really an IP STL path right into the transmitter. And remember that air chain selector, I'm coming back to that now, that comes into play now. That is what chooses whether you want to have the internal GV or another air chain on air. Now in this case, the internal one is still licensed, so the first thing you would have to do then is you would have to release the license back to the license server and then deploy it there. There's always some hiccups with licensing, but there, it's moved in the right spot now. And in that case, you can run that air chain live. So that's useful, let's say if you have to do maintenance on one, do a software update, whatnot. You could have a parallel one. You could use one license and just run on the other one, do the update on the other one, and then switch back. This could be a cold standby configuration. If you can tolerate a little bit of downtime to switch back, then that's certainly an option for that. If you want to run 2 of them, well then of course you need 2 licenses, and you'd have to apply both those. And we have concurrent inputs to our modulator, and it can be a seamless hot stand changeover if that's what you need. And depending on what LiveWire feeds you feed to the 2, it could either be locally generated LiveWire for a backup audio source, or it could be the same. It is all LiveWire inputs. Talking about emergency alerting, one feature that's in the Omnia for Nautel is we actually have an EAS tab. There's a dedicated LiveWire input you can use that is used for EAS, and if there is any audio content on that, you can choose to cut into any of the processing cores for HD 1, 2, 3, or 4, or all of them at once, and cut into the audio that way. So that is, and as a matter of fact, that's a shot from KVSC that Alex Hartman has set up, and that's how he's running that system right now. And then that brings us back to the demonstration that we have today. We believe that is really, this new architecture is really what's going to enable virtual air chains. Because while we're still tied to EAS as being the last piece in the air chain, you really can't move much. But the new developments with LiveWire, the LiveWire routing that Bill talked about earlier, as well as the new air chain topology that we have here, I think is really what's going to allow us to move your content delivery into the cloud if that makes sense for your organization.